Hi, we are going to do two examples of using our energy formula. You'll recall the energy formula is E, energy, and remember, so important, that is joules per photon. It's the energy for one photon. Energy equals Planck's constant times nu. So first example, we are told that the energy is 175 kilojoules per mole. Very typical of AP, very typical of college professors, that they'll give this to you in kilojoules per mole. And they want to know frequency. Again, that formula is joules per photon. That's by definition that formula. So that means we need to convert that unit to joules per photon. So let's do that very first. 175 kilojoules per mole. Let's get rid of the kilojoules. 1 kilojoule has 1,000 joules. So kilojoules cancel. I now have joules. And we want to get rid of moles, bring that to photons. 1 mole contains 6.022 times 10 to the 23 photons. So we do that math and we get 2.90 times 10 to the negative 19 joules per photon. Joules per photon, and that's exactly what we need for our formula. Now let's look at the formula and solve for our unknown. So remember the steps. You label everything you're given. Identify the formula. I have energy, they want frequency. I'm definitely using the energy formula. We are going to solve for the unknown, that is nu, and then plug and chug. So let's divide both sides by Planck's constant. We'll get nu equals E over H. Frequency equals energy divided by Planck's constant. So now we can plug in. Frequency will be 2.90 times 10 to the minus 19 joules per photon divided by Planck's constant, 6.626 times 10 to the negative 34. You will be given that on your AP reference. And if you're in college, you're not sure if your professor will give it to you, ask them. They usually do. They usually don't expect you to have that memorized. And remember, this is joules times second. So let's look at the units. Joules cancel, and we will be left with, so let's go ahead and do the math, 4.38 times 10 to the 14, and this will be per second for each photon. Per second, that's our frequency. Okay, nice. This formula is easy. It's easy to do this formula. And so the trick is going to become the units. Watch those units and what your professor, what your teacher, what AP gives you. Okay, let's do the second example. Again, I'm trying to make this more of a college level example, so there's a little bit of a twist on the unit. So here's our second example. We're given that the frequency is 91.7 megahertz. I'm hoping this rings a bell. I know that this might be a little outdated for you because you probably use Apple Music and Spotify. That is FM radio right there. So it'd be like 91.7 KKChem. I joke with that. Anyway, this is a radio wave. That's the frequency for a radio wave. Looking at my formula, energy equals Planck's constant times nu. The unit has to be in per second, and this is megahertz. Well, we know that hertz equals per second. That's the same thing. Here's the metric system, there's English gravitational, but we've got to get rid of that mega. So let's go ahead and get this into per second so we can use our formula. 1 megahertz contains 1 times 10 to the 6 hertz right there. And then once I have hertz, I'm just going to replace that with our per second. So we will have a 9.17 times 10 to the 7 hertz. And I'm going to go ahead and just erase that and put per second, that we're going to have per second. Now we can use our formula. So E equals H times nu, energy equals Planck's constant times frequency. Here's my frequency in per second. E's already by itself, so we can go ahead and plug in. We'll take 6.626 times 10 to the negative 34 joules times second. H, multiply it by our frequency, 9.17 times 10 to the 7 per second. Check out, seconds cancel. We're going to be left with joules. So when we multiply that, the energy will be 6.08 times 10 to the negative 26. Now what's the unit very specifically? Joule per photon. Joule per photon. Now you will most likely be asked to report energy. It would ask this, energy, they want to know what it is in kilojoules per mole. So we get this answer, and you know the mistake that students make. They're going to circle that answer. Boom, there it is. But they are one step away from the correct answer. They have to convert the unit. So let's take this, I'm going to pull it right up here, and let's convert this to kilojoules per mole. So we're going to have 6.08 times 10 to the negative 26. Again, these problems are easy. The trick will be the unit. So really, really watch the units for energy. Okay, there are 1,000 joules in 1 kilojoule. Joules cancel, we now have kilojoules. There are 6.022 times 10 to the 23 photons for every 1 mole, So energy here will equal 3.66 times 10 to the minus 5 kilojoules per mole. Interesting. This energy, small amount of energy, it really drives home the point that when you have a large wavelength, you have a small frequency and a small energy. There's an inverse relationship between the size of the wavelength and the amount of energy. And here, this 91.7 megahertz, that's really going to be a low frequency, so we have a low energy. Okay, good job, good luck.